Hey there, welcome back to Farmcraft. I'm John, this is Large Marge, and we're getting back to work on her today. And I have to admit, I've been kind of putting off the next thing I have to do, which is the oil cooler. I always find it difficult to work on something that you've already fixed once and having to go back and work on it more. It's just not fun. So when I got the machine, I noticed there was a leak in the hydraulic oil cooler. In the center here is a hydraulic motor that runs a fan. And even after cleaning it up, it continued to leak oil. So I took the cooler off, and I also checked this seal on the hydraulic motor that runs the fan. And I removed the seal and the O-ring, put in a new seal, new O-ring, and re-cored the cooler and installed that back in the machine. Tightened down the fittings, which were not easy to get to. We are ready to test this thing out. Let's start this thing up and make sure there's no leaks. And wouldn't you know it, a short time later, this is what I see. That's oil right there. And with the borescope up on top, I can see it's coming from around that seal area. But whether it's fun or not, we got to do it. So let's get to it. So here's the deal. I don't think the cooler itself is leaking. I think it is the seal on the hydraulic motor that drives the fan underneath the oil cooler. In order to get to the fan, I have to take this cooler off, which means taking off the hydraulic lines, which, if you recall, this one was very difficult for me to get. But I was able to get it with the chain wrench. Hopefully I'll be able to do that again. This one isn't as bad. Plan is I'm going to remove the fan, put it back together, and with a borescope on it while it's running, I want to see exactly where this oil is coming from. There's two places on the hydraulic motor that it might be leaking. There was an O-ring, and then there was a central seal, and either one of those could be the culprit. And then, of course, the cooler itself could be the culprit. If that's the case, it's still under warranty and I need to get it fixed. But I don't think it is. Anyway, let me get to work on getting this cooler back off of here. You guys have already seen this, so we're going to breeze through it pretty quick. There you can see the oil dripping. Stupid thing. One thing I'm going to do is put a vac track on the hydraulic tank to try to minimize how much oil I drip. So let me pop that off of there. So that's an opening into the hydraulic tank, and when I put this vacuum on here, it should make a negative pressure and help prevent this thing from leaking so much oil. Basically, when I crack the line and I see it start dripping, I'll turn the vacuum on, and hopefully it'll pull air in the line and pull the oil back to the tank, is the idea. This thing is just in a wonderful position. Yeah, this is absurd. I loosened this before by hitting it with a chisel on an air hammer, but it really tore up the nut, and I'd like to not keep doing that. Yeah, there's no room. I can't get it to bite. All right, I'm gonna make a crow's foot. I do have crow's feet wrenches, by the way. This is my jumbo set. Goes up to 2 inches. It's not big enough. So I measured the nut, and I'm giving myself 15 thousandths of clearance. I'm going to try a new blade on this thing. It's not cutting well. A smarter person would have drilled that hole earlier when I still had a good way to hold it, but I think that's going to be adequate. So that's a 1/2 inch hole, so I could stop right here and just take a file and make that into a square and use a 1/2 inch drive on it. But I don't really have a good file to do that, and I don't feel like filing that much. I already did a bunch on this, and I'm going to go a different route here. This is an old socket with a 1/2 inch drive that we're sacrificing to the cause. I stripped all the chrome off of it because you don't want to be welding on chrome. I think that came out pretty good. So the wrench is so thick, it's 1/2 inch, and that socket was, you know, not even 1/8. So I spent most of my time puddling on the 1/2 inch stock, and then I would go over and hit the socket real quick, and then puddle out here, and then go over and hit it, so that I got good penetration on both pieces. I think that's going to work. Now hopefully, oh yeah, that's perfect. Both sides. Yeah, I was worried I was going to warp it or something and have to do some filing anyway, but nope.
All right. Look at that. That actually fits.
Now, that's the easy one to get to. It's the one way back in here that is hard to get to. So that's the one I want to get first. Would you look at that? They're different sizes. Why on earth would you make those different sizes? So the other nut is smaller by that much. That's 175 thousandths. This is a hard drive magnet. I think if I just hold it in place like that, once I get it on the nut and twists, I think that'll work, right? I've never done that before, but I don't see why not. I should go this way. Got it. This thing's actually working. It's pulling that oil into the tank and then it's going down through the filter now. So that definitely helped quite a lot. That was dripping pretty rapidly, and when I would put the vacuum on, the dripping would stop. The problem was that once it vacuums to this point, it has to go through the filter, and the filter's too slow. So it kept getting full. So I did 2 of them so that I could switch back and forth. Yeah, that seemed to do the trick. That thing's not leaking anymore. All right, and what did drip went into my oil catch pan down there. I don't know if you can see that. For this one, I can just pop my little spacer off. It sure is easier having the right tools. And the battery on the vacuum just died. Good luck. It doesn't even fit. That's great. Yeah, that's clean as a whistle. That's good. So the cooler is not leaking. I gotta get this fan off. And I'm hoping I'm gonna get lucky and it's gonna be obvious where the leak is, but I'm afraid I'm not gonna be able to tell. That's what I was thinking. I'd have to test it, but that means putting it all back together, running the engine, filling everything back up with oil, and doing this all again, which does not sound very fun to me. But that might be what we're doing. All right, so there's two places this could be leaking. It could be leaking right here. There's a seal there against this shaft. And it could also be leaking out here. There's an O-ring out here that's supposed to seal. And that's actually what I'm more suspicious of. Even that's gonna leak. That's awesome. Have to drain the tank again to work on this stupid thing. Okay, here we are underneath my favorite place. So this is below the level of the hydraulic tank. So my options are drain the tank or disconnect the lines. So I can disconnect here. I might have to do that one as well. Plug them and then disconnect here and plug that. And then that will be isolated and can't sit there and drip oil while I try to figure this stupid thing out. Who's better? I'm not better. Comes like a spew. Let most of that drain out. It's not working. Of course. I think that doesn't matter really because it's coming from the motor. That's not leaking. Interesting. Makes me wonder if this thing would have kept leaking. If I had just taken the seal out and let it flow for a little while, it probably would have stopped. But didn't know that. Now we can go back up there and take a look at that stupid seal and see what's going on. God, I hate seals. So I checked out the O-ring, which goes right here. When I originally took this thing apart, the O-ring had a nick in it. It wasn't totally cut, but it was partially cut. And this looks fine. The O-ring definitely is tight against that outer surface there. But I wonder if it didn't get out of place. So adding an additional washer I don't think will help. The O-ring is not getting compressed by this or the snap ring. The O-ring gets compressed by being down in the bore and being squeezed like that. All right, I'm gonna do some investigating and I'll bring you back. So here's the deal. I confirmed the shaft size. The shaft is nice and smooth. This seal should be fine. And I think the seal is fine. I think it's this O-ring. When I take the old O-ring and run it through my finger, there's a spot I can feel where it's dented. Yeah, right there. I don't think I did that. I took too much care when I put it together. I think this thing's actually quite fiddly to get it back together right, because that O-ring has to seal against the outer face, but it also has to go past a groove for the snap ring. So I've got to get it in position, the O-ring in place, this on top, and then the snap ring on. I actually have a new O-ring because when I ordered this, they came in bags of 10, so I have plenty of them. And I'm just gonna put this thing back together, and I think it's gonna fix it. I don't want to put it back together, test it, take it apart again, and then fix it. It's just too much headache dealing with the leaking oil and everything. It's not a very good design in my view, because it's got to go by that snap ring groove, and then the O-ring wants to come off. It keeps wanting to go up into the snap ring groove. Well, that one's real close. How can I press it in? That's got room for the snap ring now. So that's in. So the question is this tight or loose under there? I can't move it. Yeah, that washer's, it's snug. So here's the problem. I would love it if I could start this thing up and run this motor like it is. But those lines are disconnected. I don't have any caps for that. The only thing I have that'll plug that is the cooler itself, which means putting the cooler back on and it filling all the way back up with oil. If I'm gonna do all that, I'm gonna put the fan on, and then I'm just gonna borescope it again and see if it's gonna leak again. Maybe that fixed it. I don't feel great about it because there was no smoking gun. Let's check that O-ring. Certainly looks good. I think we got to go with it. Torque to spec. Well, I'll tell you, if I do have to tear into this thing again, now that I have that crow's foot wrench, that makes it a whole lot easier. Not easy, but easier. The idea is I'm going to watch with this borescope, and Jennifer's up in the cab. She's going to start it. Well, hopefully it won't leak. But if it does leak, maybe I'll be able to see where it's coming from. So, okay, Jen, go ahead and start it. Okay, so I'm going to run this thing for a while at higher throttle. We will come back and we'll see how that's looking. Right now, you know, it ran for a couple minutes. It looks bone dry. It's not leaking at all. And it makes me think, maybe I got it. Maybe it's just that O-ring was out of place and it was leaking around it. I hope so. Good grief, I don't want to take that apart again. So I ran it for a good 10 minutes at higher throttle and didn't see any evidence leaking, so I went ahead and bolted everything back down. And even after sitting for a couple of days, I scoped it again, and no oil, no leaky. Something else I'm going to fix while I'm here. I've already done this one. These are the basically the way to fill or put a vacuum on the hydraulic tank. You can take this entire thing off, but then you're seeing the filter and the filter assembly under there. This is just a plug for filling. And there's 3 filters, so there's 3 plugs. This one, I milled flats on it so that I can at least put an adjustable wrench on that. But that's going to fail before long. It takes quite a bit of torque to tighten these down. There's an aluminum washer, but it's pretty big, so that central nut has to put a lot of torque to get that washer to compress. So this is the only one that I can easily access. You can see this one was all rounded off. They've been using a pipe wrench on it. This one was the same, and that's why I tried the flats. But what I need to do is this. I need nuts on there so that I can put a wrench on it and open those things up. Didn't think it would be that big of a deal, but it keeps coming up and it's really annoying, so let's fix it. This doesn't sound like much of a repair, but it's actually more involved than I thought it would be. Even requires some machining. See, that stupid thing. Well, there's one done. That was the easy one. So I'm looking at this other one, and they used a pipe wrench on the outer edge there, which dented it down into the washer. So it's really screwed up. No wonder that one has to be crammed down ridiculously tight not to leak. So I may need to look at making a new washer for that one. And obviously I need to fix this. Alright, I've got this piece of aluminum chucked in the lathe. I'm going to make a couple washers out of it. I need to turn the outside to 1.76. I often edit out a lot of the machining process because it can be tedious and time consuming, but I'm going to include a little more detail here than I usually do so that you can see how to machine things down to the thousandth of an inch. So I'm at 1.94. Take another 100 off. That's 100. 1.84. And I need 7.6, so if I go 40 and then 40, I should be there. So here goes a 40 cut, and then we'll measure again. From here on, you're going to see I have a band-aid on my thumb. I got in a fight with a bandsaw. The bandsaw won. Yeah, I'm at 1.802. 1.764. A 4 cut, and we'll call it good. Now I need the ID to be 1.53. Start out with a center drill. That's 1 inch, I need 1.53. I actually have a 2-inch bit, but that's too big, obviously, so we're going to bore it out to 1.53. Alright, so I have 1.265. So if I take off 65, I should be at 1.33. So I just dialed in 65 and zeroed it. Let's see where we are. Yeah, so there I'm at 1.33. Do a 100 cut. So I'm a little bit under, and the reason for that is because there's flex in this. The heavier the cut, the more it flexes, and it doesn't exactly line up with what you've dialed in for that reason. So that's why you kind of have to sneak up on things. So here's 55. So I'm at 1.485. I need 45 more. So there's a 45 cut. Alright, how'd we do? 1.53. Yep. Now I can part off washers. The ones that are on there are about 110 thousandths thick. So can you see that? Yeah, I've got a dial indicator here. Put it on the carriage. Zero it out. And I've got the right side of my parting tool is lined up with this face. So any amount that I move the carriage this way is going to be the thickness of the washer. So I've set this to 0. If I move it 110 thou, so there's one turn, that's 100. There's 10. If I part that off, I'll have one washer. And repeat. Well, to do one more, I'm going to have to reposition that, and I don't really need it. In fact, I really only need one. So I think I'll just leave it at that. So this one actually requires some work here. I need to fix this face, because if that's not smooth, it's not going to seal. And it's pretty nicked up from them putting a pipe wrench on that. So, and this is nicked up enough that I actually need to add some metal back to it. I'm also going to go ahead and add some metal here too, so that I can turn that down and have a spigot to hold on to it. And then eventually I will end up welding the new nut onto that. So, first thing I want to do, have this thing in the vise, and I use some aluminum against the threads so I don't have to worry about the threads getting damaged. Don't have to grab it too hard, but this thing's solid steel, so it would take an awful lot of force to warp that. So I need to add a little bit of metal back right here, and then I'm going to fill this out again, and then I'll put it on the lathe and turn that round. You'll see, we'll make it like new. Okay, now I'd like to finish out that face, but I'm going to end up hitting the jaws. And so what I'm going to have to do is grab it by the threads, but then this is in the way. I need to fix that face first so that when I push this face up against the chuck jaws, it will be square. I could probably make it work like it is now, but I've got this spigot now. Let's go ahead and grab that. Pretty good, and because this is a sealing surface, I want to get it right. Needs to be right. I am going to see if I can check and make sure I'm pretty square with this dial indicator here. You can see how rough it is. It certainly needs some work, but it's staying around 65 as I do a full spin. So yeah, that looks good. Now we're just going to do a light facing until I get a continuous cut, and then that face will be good. Alright, good enough. See, now I can take that out. I do need my soft jaws because I'm going to be grabbing threads. And then I can press those against the faces of the jaws, and that'll get that face running true. It didn't get everything, but it feels good, and you know, that will certainly do the job. And the important thing here is I now have a nice flat face without any defects in it that washer can run on and seal it up. Let's weld a nut on here and this job's done. Well, that was a lot of work, but now I actually can take those off, and that's going to be handy in the future. And I can get them to seal up. See, that's the problem, is I couldn't torque them down tight enough, and then they would leak. Because when this thing is running, it's returning oil under pressure to here. So if there's any ability for the oil to get out, it does, and this whole thing gets saturated. I got the oil topped off right where it needs to be. That thing is not leaking, at least for the time being. I don't know, it's one of those things where I didn't find a smoking gun, so it leaves that lingering doubt. But I'm calling it fixed for now. If anything changes, I will update you painfully. Let's go on to something else. Old Margie needs to go to the dentist. So I took one of the teeth off, so I have that tooth still. This one was always missing. The reason I took it off is so that I could measure it and figure out exactly what kind of teeth this thing takes. And now I have a replacement tooth. Let's throw it on there. So this thing takes an X400 tooth. Just for a little perspective, the tooth is 10 inches long. It's a little over 5 inches wide. Probably more than 10 pounds, 5 kilos, something like that. And this tooth cost, after shipping and everything, like 75 bucks. I'm just looking at how tight of a fit these pins are. There's a rubber in there. That's steel, and the rubber compresses and holds that tooth in position and keeps this from coming out, is the idea. These, I think, are in there a little, they're just not as tight as I'd like them to be. I think I may do some welding to make sure these things stay put. There we go. That one I don't think is going anywhere. These other ones I worry about. So what I think I'm going to do, get the grinder out, clean them up a little bit, and just build up some weld so that it would really need a lot of force to get it to go through that slot. It's not about welding it to the teeth, it's just making it bigger so that it can't come out. That'll be my goal. We'll see how it works. I did something similar on my little Yanmar. And you know what? While I'm going to get the grinder and get the welder and everything set up to do this, I'm going to leave this sitting here because it's on the hydraulics. I want to see how much drift there is. In person, it seems like there's none, but there's got to be some. But we'll see how long it stays in this position over time. So we'll see you back in a few minutes. Yeah, there's some drift there, but really not bad at all. Over 7 minutes, this giant boom hardly came down more than a couple inches. Alright, and the idea, you know, that I'm not really trying to weld it to the tooth. I think that'll break. But just making the pin too big to fit down through is the idea. So I think that's going to keep those teeth on there for quite a while. Sloppy welder. That guy's not getting a tip. That is far from pretty, but it's perfect because I really don't think those teeth are going anywhere now. And at $75 a pop, I don't really want to lose any. There, doesn't Margie have a nice smile now? At some point, I'm probably going to do some work on her overbite. But that's going to come later. I actually want to use this thing like it is and get a feel on what needs to change to have the thumb work the way I want it. So the next thing I want to do, we're up on top of the cab here, is set up a solar charging system for the batteries. It's a 24 volt system, so I had to get a 24 volt panel, a charge controller, and the panel is going to go right up here. Before I put the panel on this though, I figure change of plans actually. The closer I get to the bucket, the more likely something's gonna drop on this thing. I think at some point I'll go push on a tree, a limb will break off and slam right on top of that. I think the panel's more at risk there than it is here. So I can put the panel right there. The batteries are in that back corner, so I'm gonna have to go that way anyway. So I might as well just put the panel there. I don't want to put it there because of all the exhaust heat, and I don't have enough room in that spot. But right here, there's plenty of room, and what's underneath here is the hydraulic tank, which doesn't generate heat. It's right behind me in the cab. It should be the safest place on the machine. Just seems like a good spot for it. So let's do that. Now I'm just going to screw this thing down with 4 screws, couple wires. It's not a big deal. I can take it off pretty easily later, if and when I decide to do any painting. I think I am going to do some painting on this. I've done so much work, but I really want to use the machine and test it out and know that I've fixed everything that really needs to be addressed right now before I do that. I don't want to go painting it and then have a bunch of hydraulic leaks and other repairs. So it's going to be a while. The painting will be the very last thing that I do. So yeah, underneath this thing, I need to think about where I want to mount the charge controller. It needs to be in a place that's not going to get wet ever, because it's not waterproof. And I think the answer is going to be like right here, because it gives me a place to screw it to. It'll be up underneath this. It'll never get wet. So these are screws I used for metal roofing. They've got a little rubber washer there to help seal. Yeah, I'm probably going to be taking that off again in just a second, but that's fine. I need to put a hole in here for these wires. I figure I might as well put the hole underneath the panel so that minimal water gets in there. Well, doesn't that figure? Should have measured. Came right down on one of the cross supports. That was stupid. I'll just stick a plug in that. We're gonna go right here. All right, I've got this plug here to plug that. And this is a grommet that the wires will be going through. All right, I got this off of Amazon. It is a Riiiiight Wanderer battery charge controller. It was pretty cheap. Okay, so we're wired to the panels. It's giving me an error because I'm not hooked to a battery yet. The battery terminals are the center ones there, plus minus. So I just need to run a cable over to the batteries now. Now I've got this stuff. This is in a conduit already. It's actually got aluminum in there, so it's a pretty nice conduit. And it's got 4 wires. I don't need 4, but I'll leave them in there. Maybe I'll come up with a use for them in the future. Probably not. But I'm just going to route this. Well, you'll see. Basically, I'm going to try to follow the main battery cables, these going around that way, as much as possible. And they kind of come to the center of the machine over here, and then I will come up and tie into my charge controller. Yeah, so those wires aren't going to get pulled out of that now. All I have to do is some zip tying. Yeah, that should work fine when I close that door. And the starter is right there, and that's where the battery cables go. So from here on, I'm just going to follow the battery cables over. Yeah, that works. We are to the batteries. This is positive, this is negative, but this thing isn't exactly stock, and I think there's a good chance I'll be reworking this at some point. So I'm basically going to give myself like that much length so that I can reach pretty much anything. Here I'm carefully cutting the conduit, but not cutting the wires inside. I got the heat shrink to go inside the aluminum part just to protect those wires. And then we're going to do a bigger piece of heat shrink on the outside. I'm going to do one more zip tie to this cable here. Alright, so I want the red and the black. These other ones I'm not going to use. Alright, so this is the negative. Alright. And we'll do the same thing with the positive right here. Alright, let's go see if we're charging. I'm just going to check the battery voltage. So yeah, now we're 25.9. So that has gone up. And let's see if we can detect some DC current. 0. Yeah, we're getting 2 amps. All right, battery is charging. So that's a 100-watt panel. We're getting 2 amps at 26 volts. So we're getting 52 watts right now. And, you know, the sun is at like a 45-degree angle to it. So yeah, that's about what I expected. I didn't want to get too low of a panel in power and not be able to keep up. But I think that thing charging constantly every day, I don't think I'm going to need an alternator. We'll see. If I'm killing the batteries for some reason using the machine, then I will address the alternator. But I really like this setup because I can leave the machine sitting here for weeks, months, and every time I come back to it, it's going to have a topped off battery. So I would have put the solar panel in there even if the alternator was working. I'm going to see if I can just ignore the alternator and not worry about it. You know, the electric on the machine, there's a couple hydraulic control valves that are electrically actuated, and then I'm going to put a fan in the cab, a horn. Yeah, there's just not going to be any major draws on the electrical system. And with 2 batteries, 24 volts, I mean, those batteries have a lot of juice in them, I think. Yeah, we'll see. We'll keep you updated. 1 or 2 more things I want to do before I take this thing out and actually do a little work with it. That's what we're doing at the end of this video. I'm looking forward to that. So this is the throttle right here, and turn to lock. So that's unlocked, and you push down to increase the throttle, and then you're supposed to be able to turn it and lock it, but it doesn't lock when it's all the way on. So I can't use the thing at full throttle. See, when I'm up here, this is idle position. I turn it, it stops, and it's locked. It won't go up and down until I unlock it. I can push down a little bit, that'll speed it up. It'll lock again. But you notice it turned a little more. And then if I go down, yeah, there it won't lock. There, it just barely locks. So whatever mechanism is in there is worn out. And all the way down, full throttle, it won't even get close to locking. And when it's running, the throttle just immediately creeps right back up. So unless I have my hand on this holding it down, I can't run it at full throttle. There's a cable that runs to the injection pump, which is obviously where the throttle is being turned on, and the governor is in the injection pump. So all this has to do is just pull a cable and hold it. Let's see if we can fix it. This shouldn't be bad. That's not what I was expecting. The mechanism is in the cable itself. Take all this off. Let me push it down underneath and see if I can fish it out. Well, this is unfortunate. The mechanism is inside this and it's crimped on. It's not serviceable. I mean, I could cut it open, but I think I would cause myself a lot of additional work just to hold the throttle on. Well, if I could replace the part, I would. I guarantee you this is not available, like everything else that I try to get on this machine. I think what I'm going to do is just come up with a rig. I just need some way to hold the throttle and have it stay on. So let's put this back up where it was. I'll just through that hole up there and see what we can do. So the good news is the wiring all looks okay. And up, way up in the box, there's nothing around that hole. So I can drive some screws in there to rig up something. I'm not sure what I'm going to do yet, but at least I've got stuff to work with. You can see I'm in idle position. Weight on it. That almost holds it. Well, I came up with a rather absurd solution, but there's reasons for it. My first thought was to make a way that I could strap it down or have something that flips in the way to hold it down. But it's hard to get stuff like that really precise. You use a bungee cord and then the bungee gets weak and the thing starts creeping up on you. And like if I did a bungee cord, I could drill a hole in that and attach a cord and then, you know, attach it down lower. But then if I want to take the throttle off quickly, I've got a cord to fumble with, and it's one hand. You know, it's when you're in here, it's not easy to get both hands right here. So I just didn't really want to do that. And I figured rather than screwing around with that, let's just use gravity. So I had a bunch of scrap steel. I just kind of tacked it together. It fits over the handle. You push it down and it stays down. This thing weighs a little over 6 pounds, about 3 kilograms. And I think that's going to do the trick. And then when I'm not using it, it can just sit right there. A little embarrassing, bit of a farmer hack, but as far as utility and safety, I think that's a good one. You know, there's never going to be any fumbling with this. If I need to turn the throttle down, you just take that off and do what you need to do. Be pretty quick. That said, instead of letting this thing get all rusty and nasty, I am gonna throw a coat of paint on it. But you guys don't need to see that, just like you didn't need to see me welding up scrap metal. But while working on this, I have developed a new problem. I'm not even using this machine and new problems are popping up. That is not a good sign. Well, I just moved the machine. I repositioned so that I could get up underneath the cab. And I was back here. That, I think, is coming out of my final drive. Or I guess you would say the travel motor, it's hydraulic oil. Well, more content. All right, so let's see what's going on with our travel motor here. I have not opened this thing up yet. This was on the list. What's weird is I tracked this thing all the way from the end of my driveway, which is a mile to this point, and I had no problems, no leaks. And now sitting here, and I move it a few feet, and now it's spewing oil. That is odd. Anyway, it is what it is. Turn it up to 11. Broke that one off. What in the world? So you're thinking, it's just a little hydraulic leak. It won't be any big deal. Well, like most things with this machine, this turned out to be quite a job. So that's going to have to come in a later video, but thanks for watching. We'll see you on the next one.